All right, this is chapter 5.5, multiple angle and half angle formulas. It's video number 1. So double angle formulas, these are formulas expressing trigonometric functions of an angle, for example, 2x, in terms of a function of another angle, in other words, x. This will allow you to evaluate more angles that are not on the unit circle. So this is where we get this double angle, triple angle, well, in this case, double angle formula. And we want to be able to evaluate that angle because that angle is not on the unit circle. So, and this is different than what we did with the U substitution. This is where the angle x or u is actually on the unit circle, and we're taking the double of it, and then we're going to look at when we take the half angle of it. Whereas when we did the others, when we had the multi-angle, the angle that we were looking for was actually the angle that was not on the unit circle. So it was the multiple angle was on the unit circle, but the smaller angle wasn't. This one, anyway, I'm confusing things. Don't worry about it. The point being is that u or x or whatever is going to be an angle on the unit circle. So we have these, you'll be given these, but again, you need to know them, need to understand them. The proofs of these are kind of cool. I think this is actually from your book. If you look at your book at page 405, the proofs on these are kind of neat. So sine has just one straight, sine of 2u is 2 times sine of u cosine of u, tangent 2u equals 2 times the tangent of u. U is an angle. Some of you, I think, still aren't figuring that out. Whatever, that it's an angle. So this is the sine of 2 times the angle u. Tangent of 2 times the angle u. Okay, whether it's u, x, theta, whatever, we're talking about an angle. These are all angles. Okay, because we're taking the cosine, the tangent, we're taking a trig function of an angle. And I think some people still haven't figured that out. Cosine's kind of unique. It has like 3 different. So cosine of 2 times an angle, there's 3 different versions of it, and you'll use the one that kind of helps you the most. All right, so we can use it to solve equations. So here we're going to solve for 2 times cosine x plus sine of 2 of x equals 0. So we want to find x. By solving the solution, we want to find x, which is an angle, equals an angle. We want to find what is the angle that we put in here, and the cosine, 2 times the cosine of it plus 2 times the sine of that, 2 times the angle, the sine of 2 times the angle, plus the cosine of the angle times 2, all equals 0. Anyway, so what do we do? Well, we identify here, okay, we have 2 sine x. We can use our double angle formula. So we can rewrite this as 2 cosine x plus 2 sine x cosine x equals 0. Why did we do that? Well, now we have both of these terms. So here we had 2 terms, right? And the 2 terms really had nothing in common. You cannot factor out the 2, okay? Do not think something like that. Okay, you can't do that. Some of you you see something, you go, oh, they both have a 2, I'm going to factor out the 2. You can't do that. Okay, this is 2 times cosine. This is sine of 2 times angle. They're just because they're 2, they mean completely different things. Okay, but here we can do factor. Here we can actually factor out a value. So we can factor out now this. We can factor out the 2 cosine. Since this is 2 times sine times cosine, okay, it doesn't matter what order we put it in. Like here, let me do this, just so you can kind of see this. This is the same as saying plus sine x to cosine x. Okay, since it's multiplication, the order doesn't matter. So now we do have 2 terms that are exactly alike, and we can factor those out. So we have 2 cosine x, and this is 1 plus sine x equals 0. So we go 2 cosine x equals 0, cosine x equals 0, 1 plus sine x equals 0, sine x equals 1. All right, so what angle has a cosine of 0. Okay, well, this is 0. This is 0, 0, 1. This is down here. This is our unit circle. This is 0, -1. Okay, so what angle has a cosine of 0? Well, pi over 2 and 3 pi over 2. And then over here, which has a sine of 1, well, sine of 1, x equals pi over 2. Now, it didn't really say, it did not give us the restriction of 0 to 2 pi. If we did get that restriction, then we'd say x equals pi over 2 and 3 pi over 2 in our solution set. So that would be our answer. And it wasn't very clear in this. It will be clear on any test. But since it just said solve for x, we should pretty much mean that means for all of x's. So we're going to give it that general solution. So all solutions, since it didn't restrict us to say just 0 to 2 pi. So then we're going to say, okay, well, that means pi over 2, 3 pi over 2, back over here 3 pi, 5 pi over 2, 7 pi over 2, and we just keep going around and around and around. So to write that in the general solution, we would write x equals pi over 2 plus pi n, where n equals an integer, right? So, because then if n is 0, we have pi over 2. If n is 1, we have 3 pi over 2. If n is 2, back up here, et cetera, et cetera. So this is our general solution. This would be what we would want to see for that solution. Okay. Evaluating functions involving double angles, use the following to find. So we want to find the double angle, sine of 2x, cosine of 2x, and tangent of 2x. We're given the angle. It's not on the unit circle. We need to draw a triangle. This tells us that we're in quadrant 4. So we're going to come over here, here. Our hypotenuse is 13. 13. This is cosine, so our adjacent side is 5. And special right triangle means that this is -12. If you don't believe me, you can do the math. Okay, but trust me, it's going to be positive -12. And since it's Q4, B equals -12. That's why this is -12. Okay, so we now have our ratios. We're going to, we have our sides, so we can write out each of these. So let's go sine of 2u equals 2 sine of u cosine of u. So sine of 2, so equals 2. This is u, by the way. Oh, it's x. X. Let's be consistent, x. So sine, this is our angle. So sine would be -12 over 13. And cosine would be 5 over 13. So this is going to be 2 times, what is that, -60 over 169. So this is -20 over 169. Cosine of 2x. Cosine has 3 possibilities. This is probably the easiest one to do, typically, if you have sine and cosine, especially in this case. So we're going to want to do cosine squared of x plus sine squared of x. So we've got 5 19th squared, 13th, why did I say 19th, 13th squared, plus -12 13th squared. do 25 over 169 plus 144 not plus minus minus 144 169 negative 119 over 169. Okay, helps to get your formula right. Okay, tangent 2x. Should we check our formula? Our formula is going to be 2 tangent x, 1 minus tangent squared x. So let's put that in. So 2, all right, tangent of x is negative 12 over 5. And this is going to be 1 minus negative 12 over 5 squared. Minus 144 over 25. What is this? Negative 24 over 5. This would be 25 minus 44 is what, 119. So this would be 119 over 25, right? 24 over 5, 25 over 119. Is that right? That goes into here, 5, 5. So 5 times 20, let's see. I did 1 minus. Oh, this is negative. That's what. Okay. It's like, I know there's a negative here because this winds up being positive. There we go. Sorry. A little bit of a 119. Okay. Forgot about this negative here because this is 1. This was right here. This was 25 over 25 minus 144 over 25. So that's why it was negative 119. All right. And then negative over negative is positive. It seems like that. Okay, so that was